So I'm going to begin with some motivation, talk a little bit about a essentially conventional approach to certification, and then discuss some attributes of Agile certification, or at least how I'm using that term. So, by way of motivation, I thought this extract from the introduction to the proposed EU Cyber Resilience Act expressed it quite nicely. It says that hardware and software products suffer from two major problems, adding cost for users and society. Firstly, they have a low level of cybersecurity, and secondly, an insufficient understanding and access to information by users, preventing them from choosing products with adequate cybersecurity properties or using them in a secure manner. So I think that expresses quite well what product cybersecurity certification is trying to achieve. So in order to sort of scope the problem a bit more clearly, I've got a fairly typical scenario sketched up here, involving three stakeholders. Firstly, the regulator, who's really what he or she wants to see is that the end user, the citizen, whatever, has access to online services that are secure and trustworthy. The provider of such services that make use of IoT products is an operator of a system of which the IoT product is a component. The system operator goes out to the market, issues some statements of requirements to various manufacturers, gets some responses back, has to select a product that not only fulfills the functional needs, but also results in the desired security properties of that operational system when operated in the environment in its environment, which includes, amongst other things, threat agents. The manufacturer or supplier is making a series of product instances which are essentially similar, and they must perform their function and offer adequate security when operated in a variety of contexts posed by the various customers. And certification offers advantages to all those parties. Right. So, what does development of a certification scheme involve? Firstly, I'd just like to say that I'm not making a big distinction between voluntary certification and mandatory regulation, or indeed between self-certified and third-party certified schemes. But basically the scheme starts off with a set of principles or required or desired properties, and these are typically fairly general and to a large extent independent of operational context, broadly speaking. However, to make them sort of actionable, actually useful in practice, they need to be expanded upon more explicitly within a standard that may well apply to particular sets of operational contexts, industry, type of device, etc. Then we need to be able to determine whether the product actually conforms to that standard. So we need evidence-based compliance criteria. And finally, we need to determine who is authorised actually to perform that compliance assessment. And looked at it from the customer point of view, application of the scheme involves development of the product to standard, assembly of the required documentation and submission for assessment, either internal or external. Those assessors establish whether it complies or not, and a certificate or statement of conformity is issued. So I think that's a general flavour of what is involved there. And there's quite a bit of relevant legislation and frameworks and standards about at the moment in various stages of maturity. These include the European Cybersecurity Certification Framework, which is not a certification scheme, but a framework for development of certification schemes. And there is intended to be a rolling work programme of certification schemes within that framework. And last time I looked, it seemed to be that the IoT and industrial control system schemes may be in the pipeline. They weren't actually on the work programme yet, but they were strong candidates to be on the work programme. Also out of Europe is the proposed European Cyber Resilience Act. So that is a regulation, so it will be mandatory, on cybersecurity of products with digital elements. So certainly I think that includes IoT devices, but is intended to be broader than that. And potentially that there are fines of up to 50 million euros or 2.5% of global turnover involved for violation of that. But it's still in draft. So we've just heard about the UK Product Security and Telecoms Infrastructure Bill, which is closely related to the UK Code of Practice, which strongly influenced, let's say, NCEN 303-645. So those are about consumer, specifically consumer IoT products. There is a conformance methodology associated with EN 303-645. There's also in the US a NIST Cybersecurity White Paper, I think is what CSWP stands for, that responded to an executive order from the president over there to look into, to recommend criteria for cybersecurity labelling for consumer Internet of Things products, and that builds on those IR documents. And of course, we have our own dear IoTSF security framework. So if you look at the principles or basic principles or minimum security objectives, there's a fair amount of compatibility with those schemes. Certainly I would say there isn't a contradiction there. I've just brought out the minimum security objectives for the EU Cybersecurity Certification Framework as an example. So there's three objectives to do with traditional security triad of confidentiality, integrity and availability. There's three to do with dependencies and vulnerabilities. There's another couple to do with auditability. Sometimes the schemes talk, rather than auditability, talk about being able to monitor compliance, assure it in a continuous way, etc. Recoverability is important, strongly related to resilience and security by design and default. So I think it's a fairly typical set of principles. Right, so and these confer, at least in theory, advantages to those three stakeholders. Regulator, for the regulator, these schemes incentivize suppliers to improve security of products. They protect honest suppliers from unfair competition. They educate customers. They're more secure and resilient. They result in more secure and resilient services available to society. And, well, I won't read out the whole of that slide. But in principle, at least, there's benefits for all. However, there are problems in practice. Firstly, that these schemes tend to be time-consuming and labour-intensive, and that can delay market entry, increase cost and hence price, and lead to a competitive disadvantage. So, if your competitor is not going through certification, and you are, it's quite likely your product will be late and will be expensive. So unless the certificate is valued intrinsically by customers, then there's a limited incentive to certify products. If compliance is made mandatory, then there's a tendency to turn it into a tick in the box exercise. Another issue is that the pace of technical change is faster than the certification timescale. So I had cause to look at FIPS 140 certification. So that's a scheme to do with hardware security modules, and there it was, the word was it took about 12 to 18 months to achieve certification. So by the time, with the pace of change of IoT devices, they may well be out of date by the time they're certified. Certification schemes themselves take a long time to develop and tend to lag the market. You have to, before you standardize stuff, you've got to have an idea of what's good and what's bad practice, and that requires some experience. Also, the variety of IoT products and the context in which they are used mean that many different standards and profiles are required. So, so you might have a set of standards that apply to the healthcare domain. Then maybe you have to have different standards for different types of healthcare devices used in different contexts. So certification applies to one product version at a point in time. So what happens if the product changes, or how much does the product have to change before recertification is required, etc. In the interest of time, I won't go through everything. But there is a question that, having gone through this process of certification, is the result actually an increased security, or is it just another bit of paper that may or may not help in the market? So, if those are the problems, what are the solutions? Well, I'm hoping you'll help try and answer that. I had a go at trying to define some goals or principles for what I'm calling Agile certification. I haven't coined that term, but sort of this is how I'm interpreting it. So firstly, and this may seem a bit obvious or redundant, the scheme is and remains fit for purpose. So it's got to be firmly focused on the needs of customers in selecting products, operating them securely as part of a larger system, and assuring the security properties of the system. And as the needs of the customers evolve, then the scheme has to evolve as well. Of course, that raises problems for what happens to devices that are already out there in the field. Do they have to be retrospectively modified, etc.? Okay, the process has to be lean and mean with little overhead in costs or time. So certification should add value and not reduce it. So I would argue that certification or analogous regulations should be about encouraging firms to adopt best practice. So you shouldn't regard certification as something extra. It is just providing evidence, some acknowledgement that you're doing your job properly. So it shouldn't extend the time it takes to develop and operate and maintain the product. Harmonisation and modularity of certification schemes is important. You know, I mentioned earlier on that the objectives of the various schemes and legislation were compatible, not identical but compatible, and I think the previous speaker said something similar. So why do you need all these different things? And if you do have different schemes, well, we ought to at least be able to leverage one certification to gain another. Just have to do the additional things that are required by the other scheme. I think taking a whole life cycle approach is important, and that means two things here. One is that your certification of related activities should be integrated with the other processes like development, like product support, etc., and not something distinct and added on. But secondly, that certification should be integrated end to end, from retirement to from requirement to retirement. So maybe we can call that DevSecOps cert. Right. Some other goals. So I think it's important to take a holistic view, linking not only the development and maintenance of the scheme, of the obtaining and maintaining certification, and the actual operational life cycles of the product. So I'd see those as three coupled processes with feedback between them that allows them to maintain appropriateness and fitness for purpose. Intelligent automation and support is necessary, and I think I'd go along with what Nick Hallett was saying in sessions this morning, what he was talking about as cognitive security, I think he calls it, but certainly having a clear declarative semantics and some sort of logic for reasoning about claims, evidence and trust. Recursive decomposability. Well, basically, previously I talked about three levels: the IoT product, which is operated within an operational context, which is operated within an environment. But also you can go down within the IoT product to the IoT device, and I quite like the differentiation that NIST made between the device and the product, with the IoT product being the device plus the components that are necessary to use it. Components in typically software components. Then you have components within the device and maybe components within the components. So we should be able to hopefully leverage certification down here in order to obtain certification up here or assurance up here. However, it's not just a simple equation that, well, if all your devices are certified, then your operational context is secure. But at least, we should try and be able to reason about it. Yeah, won't go through that, but this is an attempt at drawing up this set of coupled processes. So conclusions, you'll be relieved to hear. So we need to raise, I think it's acknowledged that we need to raise the level of cybersecurity in IT products and the systems that they're deployed in. There are many initiatives, as I've tried to show, both monetary and voluntary. Typically, conventional schemes are fairly static and fairly sluggish and paper heavy. Agile certification, the concept is intended to take a dynamic whole life cycle approach to reduce costs, automated maintenance, etc., 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 to resolve problems in conventional schemes. And the call to action is really to recognise the need to establish an Agile certification research agenda to bring together a number of related strands in order to address these many challenges. Now, if we have time for questions, I'm happy to take them. If not, I think I invite you to take the advantage of raising these at the session later.
Sure. We've got, I think, a couple of minutes. So